Hi folks, so welcome to the lecture where we're going to look at our standard form, where we're going to be looking at positive as well as negative indices. Now standard form is also known as scientific notation. It involves writing large numbers or very small numbers in terms of the powers of 10. Now for a number to be in standard form, it must take the form a times 10 to the power of n, where n is a positive or negative integer, and a must be in the range of between 1 and less than 10. Okay, so it has to be between 1 and the number 10, otherwise it's not in standard form. So, for example, 2,350 can be written in many ways. There's 2.35 times 10 to the power of 3, or 23.5 times 10 to the power of 2, or 0.235 times 10 to the power of 4, etc. However, out of the three options that I've given you, 2.35 is the only number that happens to fall within the 1 to 10 range. So, 2.35 times 10 to the power of 3 is the only one that's actually written in standard form. Now, on the other hand, looking at a really small number, we have 0.00367. It can also be written in many different ways. So there's 3.67 times 10 to the power of negative 3, or 0.367 times 10 to the power of negative 2, or 36.7 times 10 to the power of negative 4. However, once again, there's only one option here that actually falls into the standard form mix. 3.67 is the only number that happens to fall into that 1 to 10 range. Everything else falls outside of it. Therefore, 3.67 times 10 to the power of negative 3 is the only one that has been written in standard form here. So, let's put this into practice with a few questions. Okay, so this question says, which of the following is not in standard form? Okay, so let's have a look. So we have A as 4.7 times 10 to the power of 7. Now, this number, as we can see, does in fact fall into this particular range here. So if you were to look at, if you were to assume that the 4.7 is A, then A does in fact fall within the 1 to 10 range. Okay, so it's between those two numbers. That means that 4.7 times 10 to the power of 7 is in fact A in standard form. So that should be a yes. Okay, now let's have a look at B. Now B, on the other hand, we have 78.6, which obviously does not fall into this particular range here. Therefore, it is not in standard form, so that's a no. Then we have 8 times 10 to the power of negative 9. Once again, the number 8 does in fact fall into this particular range here. Therefore, once again, it is, in fact, in standard form. And the same thing goes for D as well, because 6.75 does fall into that range. And obviously, all the four options that have been given to us have been written in terms of the powers of 10. So once again, that is a yes. It is, in fact, in standard form. Let's have a look at a few more questions. Okay, so this question says, write the following in standard form. Okay, so we have 600,000. Okay, we have 600,000 that we need to write in terms of standard form. Now remember, folks, I'm just going to write it in the corner here. That is what the number that we are writing in terms of the power of 10 has to fall into. That's the range that it needs to fall into between the number 1 and the number 10. Now, let me use a different color here. 600,000 can also be written as 600,000.0 if we were to write it as a decimal. Now remember, we have this particular number here that does not obviously fall into this range here. To make it fall into that particular range, we would have to move this decimal point 1, 2, 3, 4, and then 5. Because moving the decimal point right there turns this number into 6.0. And then we can write it in terms of the power of 10, so times 10. Now, the number of spaces that we moved backwards is the actual power for the number 10. So since we moved 5 spots backwards, that is times 10 to the power of 5. Okay, now let's apply our knowledge to part B. Now part B is 75 million, which is written as 75 and 6 zeros. Okay, so once again, let's write this out as a decimal. Okay, so that's 0.0. Now remember, in order for us to get this number down to, this range here, we would have to get the decimal between the 7 and the 5, because that will turn it into a 7.5. which is the only number that falls into the 1 to 10 range. Okay, so that means we'll have to move it 1, 2, 3, 4, 5, 6, 7. We'll have to move it right there. So that will turn it into 7.5 times. Now we moved it 7 spots, so that'll be times 10 to the power of 7. Okay, and now this folds in and makes it into the standard form, because the number right there falls between 1 and 10, and obviously we are writing it in terms of the power of 10, so that makes it in standard form. Alright, now let's have a look at C and D. So for C, we have 68 times 10 to the power of 8. Now once again, this particular number does not fall into this range here. So let's write it out as a decimal to start off with. So 68 written as a decimal is simply 68.0. Then to turn it into a number that falls between 1 and 10, we'll have to move the decimal point 1 spot to the left. So let me write it a little bit better. So there, right there. So that turns it into 6.8 times. Now we need to be a little bit careful here. We have moved the decimal point 1 to the left, which means that in order to make it into 68, we'll have to write it as 6.8 times 10 to the power of 1, and then we have this 10 to the power of 8 left over. Because 6.8 times 10 to the power of 1 actually gets it back to 68, which is what we had in the first place. And then we have this 10 to the power of 8 sitting on the side there. So to combine these, we have 6.8 times, we have 10 to the power of 1 times 10 to the power of 8. Using our knowledge of the first index law, where we know if the bases are the same, the powers simply get added. So that turns it into 10 to the power of 9. Alright, now let's have a go at part D. Part D is 50 times 10 to the power of 4. Okay, now 50 written out as a decimal is 0.0. Okay, so to get it into a form where it's between the number 1 and 10, I'll have to move this decimal point 1 to the left, making it into 5.0. Once again, to turn it back into 50, I would have to multiply by 10, okay, because we have made the number 10 times smaller, I guess, or 10th of the original number. So it went from 50 to 5. So in order to get it back to 50, I'll have to multiply it by 10. And then we have this times 10 to the power of 4 sitting there as well. And this 10 obviously has a power of 1. Now combining these two, again, using our knowledge of the first index law, that turns it into 5.0 times 10 to the power of 5. So that right there is in standard form. Fantastic. Now let's have a go at parts E and F. And folks, if you're feeling comfortable, please feel free to have a go at these questions yourself. Okay, so for part E, we have 0.4 times 10 to the power of 10. Okay, now to turn this number into something that falls between 1 and 10, I'll have to take this decimal point and move it 1 to the right, because that will turn it into 4.0. Now, again, being a little bit careful, now we have made the number 10 times bigger. So we need to multiply it by 10 to the power of negative 1 this time, so not positive 1, because multiplying by positive 1 will basically just means 4.0 times 10, which is 40. 40 is not what we're looking for. We are looking for 0.4. So we actually need to make the decimal point go backwards when we write it out in this form here. So it's 10 to the power of negative 1, and obviously we still have the 10 to the power of 10 left over. Once again, using our knowledge of the first index law, we simply combine these two. So negative 1 plus 10 gives us to the power of 9. So 4.0 times 10 to the power of 9. Okay, now moving this decimal point one place to the right, we'll turn it into 6.73, which does fall into the range of 1 to 10. Once again, since we moved the decimal point 1 to the right, we have to multiply this number by 10 to the power of negative 1. If we had moved 2 spots to the right, we would have multiplied by 10 to the power of negative 2. 3 spots, 10 to the power of negative 3, etc. So the lesson here is, if we are moving the decimal point from the original number to the right, then we multiply by a negative factor or negative power. If we're moving it to the left, then we have to multiply by a positive indice. Okay, then we have the 10 to the power of 4 left over. So 6.73 times negative 1 plus 4 is simply to the power of 3. Fantastic. Now, let's move into the next set of questions. Okay, so these questions says, write the following in standard form again. All right, so we have A, which is 0.0007, okay? So once again, obviously this does not fall into this particular range here, where the number has to be between 1 and 10. Now for us to turn this particular number into a number that's between 1 and 10, I'll have to move this decimal point 1, 2, 3, and 4, because what that does is that it turns it into 7.0, which is 7, and obviously that falls within that range there. Now remember, as we discussed, if we're moving the decimal point in the original number to the right, then we have to multiply by a negative indice. Now since we moved it 4 spots to the right, that'll be multiplied by 10 to the power of negative 4. Then, if we are doing B, we have 0.000056. Okay, so same thing. Taking our original decimal point, we move it 1, 2, 3, 4, and then 5, which turns it into 5.6 times 10 to the power of, now we've moved 5 spots to the right, so we're multiplying by 10 to the power of negative 5. Fantastic. Let's have a go at part C now. As you can see, it's a fairly repetitive process, folks, so if you're feeling comfortable, please feel free to pause the video and have a go at the next 4 questions yourself. So we have 0.000437. Then moving the decimal point to a place where it turns it into a number between 1 and 10 is right there. So that turns it into 4.367 times 10 to the power of, we know it's negative because the decimal point is being moved to the right, and it got moved 1, 2, 3, 4 points. So that's 10 to the power of negative 4. Okay, let's have a go at part D now. So we have 68 times 10 to the power of negative 5. Okay, so once again, we have the decimal point right there to begin with. We have to move it 1 spot to the left this time to turn it into a number that's between 1 and 10. So that turns it into 6.8. Now, since we moved the decimal point 1 to the left, our power will be a positive 1. So it'll be times 10 to the power of positive 1. And then we'll have the times 10 to the power of negative 5 left over. So we have 6.8 times 10 to the power of, we have to the power of positive 1 and to the power of negative 5. You combine those two, or you add those two, and you end up with negative 4. So 6.8 times 10 to the power of negative 4 is the standard form of that particular number. Okay, now let's have a go at parts E and F. Okay, so for E, we have 0.038 times 10 to the power of negative 6. Now to turn this number into one that's between 1 and 10, I'll have to move the decimal point 1, 2 spots to the right. So that turns it into 3.8, which is obviously between 1 and 10. Now, let's times that by 10 to the power of negative 2. Because remember, we moved the decimal point 2 spots to the right. So we have to multiply by a negative power. And then we obviously have the terms 10 to the power of negative 6 still left over. Combining these two, we have 3.8 times 10 to the power of negative 8. And finally, we have 0.04 times 10 to the power of negative 8. So moving it to a point where it's between 1 and 10, that would be 1 and 2, which turns it into 4.0. Again, 2 spots to the right, so times 10 to the power of negative 2, with the times 10 to the power of negative 8 left over. Combining these two, we get times 10 to the power of negative 10. And there we have it. That's how we turn really small numbers into standard form. Okay, so the trick is to make sure that you move the decimal point to such a place where the number turns into one that's between 1 and 10. Okay, so let's have a look at the last set of questions. So this question says, find the value of each of the following and write answers in standard form. Okay, so let's have a look. So we have A, 5.6 times 10 to the power of 3, multiplied by 2 times 10 to the power of 4. Okay, so we have 5.6 times 2, which gives me 11.2. And then we have times 10 to the power of 3 and times 10 to the power of 4. So that's times 10 to the power of 7. So once again, using our knowledge, we know that the decimal point will go 1 to the left to make it into 1.12, which makes it fall into this particular range here. And since we moved it 1 to the left, we have to multiply it by 10 to the power of 1 with the 10 to the power of 7 left over. And combining these two, we have 1.12 times 10 to the power of 8. Okay, moving into B. We have 3.8 times 10 to the power of negative 2. This time it's a division. So divided by 2 times 10 to the power of 5. So let's isolate this portion first. So 3.8 divided by 2 gives me 1.9. And then we have times 10 to the power of negative 2 divided by 10 to the power of 5. Now using our knowledge of the second index law, we know that that simply becomes times 10 to the power of negative 7, because we take that and we minus it from that. So 1.9 times 10 to the power of negative 7 is already in its standard form. So we can leave it just like that. We don't actually have to convert it anymore. Let's move into questions C and D. Okay, so we have 8.5 times 10 to the power of 7 times 4.3 times 10 to the power of 12. So let's multiply 8.5 and 4.3, which gives us a value of 36.55 times, then let's multiply 10 to the power of 7 and 10 to the power of 12. So just according to the first index law, we simply add the powers, so that makes it into 10 to the power of 19. Okay, now using our different color again, let's move the decimal point one spot to the left, which makes it into 3.655, which is obviously between 1 and 10. And since we moved it 1 to the left, we have to multiply it by 10 to the power of positive 1. And obviously we still have the 10 to the power of 19. So combining these two, we have 3.655 times 10 to the power of 20. Okay, let's have a look at this question. So we have 9.6 divided by 2.4, which is simply 4.0. Then using our knowledge of the second index law, we have 10 to the power of negative 11 and 10 to the power of negative 5. Combining these two, we have times 10 to the power of negative 6, which is simply negative 11 plus the 5 at the bottom there. And this already is in its standard form, so we don't have to do anything further. Now, folks, as you can see, it's a fairly repetitive process. We're not doing anything different as we go from question to question. So what I urge you to do is pause the lecture at this stage and have a go at parts E and F yourself, and we'll come back to it in a few seconds. Alright, so we have 2.4 times 10 to the power of negative 8 divided by 6 times 10 to the power of 3. So 2.4 divided by 6 is simply 0.4. And these two, using the second index law, gives us times 10 to the power of negative 11. Then moving our decimal point one place to the right, which turns it into 4.0. Then since we moved it one place to the right, we have to times by 10 to the power of negative 1. And we have 10 to the power of negative 11. Combining these two, we have 4.0 times 10 to the power of negative 12. Fantastic. Now, having a look at 2.3 times 10 to the power of 5, divided by 9.2 times 10 to the power of negative 6. 2.3 divided by 9.2 is simply 0.25. Then we have times 10 to the power of 11, as we combine 10 to the power of 5 and 10 to the power of negative 6 together. Moving this decimal point 1 to the right turns it into 2.5. So times 10 to the power of negative 1, because we moved one spot to the right, times 10 to the power of 11. Combining these two, we have 2.5 times 10 to the power of 10. So there you have it. That's how we convert anything into standard form. It is a really important practice when it comes to math. So folks, I really do encourage you to pay extra attention in this lecture and go through it a couple of times if you really need to. So thank you for paying attention, and I will see you in the next lecture. Bye, guys.